Okay, welcome back to statistics. We are continuing our pretest number 2 here. Let me go ahead and bring up a little page so I can write on it, and we'll bring up our thing right here. So for problem number 5, how are your grades? Recent semester at a local university, we had 400 students enrolled in both statistics and psychology. Of these students, 70 got an A in statistics, 69 got an A in psychology, and 41 got an A in both. Render answers to four decimal places as needed. Okay, so problem one, what is the probability that a randomly selected student got an A in statistics or psychology or both? So what we're going to do is we're going to say we have probability that they got an A in statistics, that's P of S, plus probability that they got an A in psychology, that's a SP or PSY, that's the Greek letter for psi, minus the probability of S and, okay, psi. Okay, so we have probability of, and this is equal to probability of S or psi. Okay, that's what that looks like. So we're going to go ahead and figure out this probability here. So we can say, okay, what was the probability that they got an A in statistics? We're going to say that that is going to be 70 got an A in statistics. So we have 70 over 400 plus 69 over 400 minus who got the A in both of them. Okay, and that was 41 got an A in both, minus 41 over 400. So we're going to go ahead and type this into the calculator and get an answer. Okay, so we've got 70 plus 69 minus 41, and that's going to be our answer for that. So we have 98 over 400. Okay, and that's going to be our probability. So we go back to a calculator here. We'll say divided by 400 and get our answer is 0.245. So 0.245. We're going to write that down in our answer. So let's see here. We have 0.245. 0.245. Okay, next one. The randomly selected student did not get an A in psychology. Be careful when you're reading these things because that's what tricks you up. So we're going to look at the psychology. 69 got an A in psychology. How many people didn't? So we're going to say this is 400 minus 69. This is all over 400. So we can go ahead and calculate what this is going to be. So we have our 400 minus 69 equals, and it's 331 over 400. 331 over 400. And what's that going to do for us? Okay, divided by 400 equals 0.8275. So 0.8275. That's going to be our answer for that second part of it. All right, so let's see here. We have, okay, right here, 0.8. What was my answer? 8275. 8275. Let's go with 8275. All right, and then we'll go ahead and we'll check and we'll see what happens with this guy. All right, yay, we got a good answer. Let's move on to problem number 6. All right, I love this problem. The reason why I love this problem is because it gives you the graph, it gives you the data in a table, which I think is a fantastic way to do this. So 6 children. There are 25 students in this person's class. On a cold winter day in February, wasn't too long ago, many of the students had runny nose and sore throats. And then she took a little survey and figured out what kind of illness this kids had. Okay, like what symptoms were they having? So we're going to go ahead and write this guy down. So we're going to say this. We have a sore throat. Okay, we're going to say no, sore throat. We're just going to abbreviate it as ST. We have a runny nose. We'll abbreviate it as RN, and we'll just say no, runny nose. Okay, and we'll just go ahead and we're just going to recreate this chart here. So we have 6 and 4 and 12 and 3. All right, and there we go. So let's see. What is the probability that a child had a runny nose? Well, we're just going to look at the runny nose. We don't care about the sore throat. So we're going to say this is 6 plus 12 all over 25. There are 25 kids in the class. That's going to give me an 18 over 25. Okay, so we can go ahead and write that down. I wish I could leave my answers as fractions. I wish it would take both because I know you guys don't like the fractions, but I do. And it makes it easier to look at what's going on here. So that's 0.72. Okay, 0.72. We're going to go ahead and put this in here right now. So sore throat. Okay. Oh no, runny nose. We were looking at the runny nose. 0.72. Okay. How about the sore throat? Okay. So for the sore throat, we're going to weed out the ones that had the sore throat. So we're going to say this is 6 plus 4 all over 25. 6 plus 4 is 10 over 25. And we'll go ahead and put this in a calculator and say, okay, we need 10 over 25. So 10 divided by 25 equals 0.4. Okay, 0.40. Uh, I'm going to read them all as like dollars and cents just because I'm used to doing it that way, but you don't need that. And the computer will yell at me for only doing it to zero point 0.4. It'll yell at me for saying 0.40 rather than zero point 0.4. Like, yeah, whatever. Okay, so we have to say, let's get that out of there, 0.40. Okay, so we're going to go ahead and say that. We want the probability that the student had a runny nose or a sore throat. Hey, we're looking at the probability of a runny nose or a sore throat. Okay, so what's this going to mean for us? We need the probability of a runny nose plus the probability of a sore throat minus the probability of a runny nose and a sore throat. Okay, so we can go up to our table and look at that. So the runny nose, we calculated that out. That was going to be 18 out of 25. Plus the sore throat, that was going to give me 10 over 25. Now, if I just add these two pieces up, we get 28. We only got 25 kids though, so that's going to be a problem. Minus, now, well, this is one of the reasons I like this problem, is that the intersection, if you look at the table, the intersection of runny nose and sore throat, that gives me 6. So we can just go ahead and calculate this out. So we have 18 plus 10 minus 6, and that's our next value there. So we have 18 plus 10 minus 6. Okay, and we have 22 over 25, so that equals 22 over 25. And that's going to be our next value there. So 22 divided by 25. And voila, we get 0.88. Okay, let's go ahead and write that down. So it's going to be 0.88. All right. Oh, and the last one. The probability that a randomly selected child had neither a sore throat nor a runny nose. Okay, so neither. So we can go here and we can say no sore throat, no runny nose. So really we're looking at this guy right here in the column. So we want 3 over 25. Okay. We could also say, we had, these are the children that had one or the other or both. Well, for the people who had neither, that's going to be 1 minus 22 over 25, or 25 over 25, that's 1, minus 22 over 25 is equal to 3 over 25. I kind of like this because I figured it out two different ways and I got the same answer, which makes me really confident that I'm getting the right answer on this problem. So we're going to say, okay, this is going to be 3 over 25. So 3 divided by 25. There we go. And we'll go ahead and hit equals for that one. And 0.12. 0.12. Okay. So we'll go ahead and write that down. So this one was 0.12. All right. So there we go. This is problem number 6. Okay, let's go ahead and check this one. Okay, hooray, we got the right answer. We can move on to the next one. We'll continue. Okay, so here we go. Business projection. All right, this looks like an expected value problem. We have an investor is considering an investment in a startup company. She estimates she has a probability of 0.39 to see a $23,200 loss, a probability of 0.23 for a $7,500 profit, and a probability of 0.10 to see a profit of $36,000. Oh, and the last one, probability of 0.28 of breaking even. Okay, profit is 0. What is the expected value of the profit? Okay, so this is a great problem because I love the expected value problem. So we'll go ahead and we'll do this. So expected value, that's the fancy way to write it, is equal to the sum of the value of the event times the probability of the event. Okay, that's the sum, this is the capital sigma. Little sigma, we met with standard deviation. Capital sigma kind of looks like a backwards 0.3. Okay, so what I'm going to do is I'm just going to go ahead and write down a little table. So we're going to say this is going to be X, or we'll say P of X right here. Okay, so I want the probability and the value. And then what we're going to do in the next column is we're going to say value of the event times the probability of the event. Okay, and that's how we're going to set this thing up. So let's go back and read it. So let's see. We have a probability of 0.39 of a $23,200 loss. So 0.39, and then we're going to say negative 23,200. Okay. The next one, we have a probability of 0.23 of a $7,500 profit. Okay. And then we finally have 0.10 of 36,000. So we'll go ahead and say I want 36,000. 0.10 of 36,000. Okay. And then the last one we have 0.28 of nothing. Okay. I want to do one thing before I just jump into doing this problem is I do want to see if these probabilities actually add up to one. Okay, because if it didn't, then I would have forgotten something, and I don't want to do that. So 0.10 plus 0.28. Look at that. Probably they all add up to one. Okay. Next part of the problem, what I'm going to do is I'm going to multiply the first and the third, first and the second column together. So we're going to say 0.39 times, and let's see, was this 23,200? Okay. There's a negative in here. I'm not going to put it in a calculator because it's cumbersome, but we're going to say this is negative 9,048. So negative 9,048. Okay. Next one, we have 0.23 times 7,500. Just going to write that down. 1725. 1725. Okay. Next one is zero point 0.1 times 36,000. Okay, it's going to be 3,600, but there we go. Okay, 3,600. And I'll do the hard one. 0.28 times 0. Okay. Now, what we have to do is we have to add all these pieces up. I'm going to take this one plus this one minus the 9,048, and we'll go ahead and do that. Okay, so I have 3,600 plus 1,725 minus 9,040, because that was a negative sign there, so don't forget that. So equals, and I got negative 37,000, or negative 3,723. So negative 3,723. That doesn't look like a good investment to me. Okay. So as I'm looking at this piece here, we'll say the expected profit is, we'll go back over here and say what's going on with that. 3,723. Okay, let's go back over here. We have negative 3,723. All right. And that looks like what we're trying to do for that one. Let's see. Can we check it? Yeah, sure. Let's check it. Ta-da, we got the right answer. Should you take this investment? Well, this is an expected loss here. I would say maybe not, right? Because you're expecting this person some money, and then they're going to lose it. So let's not invest with this. So we'll go ahead and we'll say check. We'll say hooray, and we've got our problems 5, 6, and 7 there. All right. So I'm going to go ahead and hold us there, and we'll do another couple of few problems in a moment. I'm going to say thank you very much for watching the video, and I will see you in the next one. Take care.